Hello guys. In continuation of the previous video where we have solved exercise 7b from new syllabus mathematics 8th edition, we have solved question number 5. Now question number 6, a cone has a circular base of radius 6 millimeters given that the curved surface area of the cone is 84 pi millimeter squares. Uh, find its slant height. Very well, the curved surface area is equal to pi RL for a cone, and it is given to be equal to 84 pi, which is equal to pi. R is to be 6 millimeters, and L we have to find. The slant height we need to find. So slant height is equal to 84 pi divided by 6 pi. This pi will be cancelled by this one, and 84 divided by 6 we get L equals 14 millimeters. This question was very simple. Moving to the next question, we have a cone has a total surface area of 1000 centimeters squares. Total surface area of a cone. Before reading the question further, keep in mind that total surface area of a cone is basically the sum of pi RL, its curved surface area, and pi r square, its base area. A possible slant height and radius of the circle. Find a possible slant height and radius of the circular base. Take pi to be equal to 3.142. As you see that this one is an open-ended question, so it's up to you that what possible slant height you can find by considering any radius. So we had question number 4 of this exercise, which was also up to you people that what values you decide. So total surface area we need to find. Let's assume that R is equal to 15 centimeters. It's up to us that what value do we select, and then total surface area will be equal to surface area is equal to in this two pi r l plus pi r square. We can take pi as common, and r also, it will be l plus r. Putting the values of 15 centimeters, surface area is equal to, which was equal to 1000. Let's say that surface area is 1000. It is equal to pi is 3.14 multiplied by r is 15, and then we get L plus 15. L we have to find, it is equal to 1000. So 1000 is divided by 3.14 multiplied by 15, which is equal to L plus 15. And then slant height L will be equal to 1000 divided by 3.14 multiplied by 15, and whole value will be, we have to write whole value minus 15. And solving this equation by using the calculators, we get L equals 6.22. L is equal to 6.22, correct to three significant figures. So it was up to you. You could take the value of R to be equal to 15 or 20 or any other value. Even you could take it 10. So moving to the next question, question number 8. An open cone has a slant height of 5 meter and a curved surface area of 251 meter squares. Find the radius of the cone. Radius of the circular base is basically the radius of the cone. So we are given the curved surface area, which is equal to 251. So 251 is equal to, formula for the curved surface area is pi RL. Putting the values, we get 251 equals pi as it is. The value of R we need to find, and L is equal to 5. So it is 251 divided by 5 pi, which will be equal to the value of the R. And in this question, R is equal to 16.0. correct to three significant figures. Moving to the next question, question number 9, find the order of rotational symmetry of the following cones. So how many times do we rotate this to get the same image? And keep in mind that a circle has infinite order of rotational symmetry, and so have the cones. A cone has infinite order, so you just need to write its order to be equal to infinite. Question number 10, for right circular cone state the number of planes of symmetry. Number of plane. Now let's see what a number of what a plane is. It means that if we have a cone like this, forgive me for my drawing, let me draw it again, and it should be like this. Yeah, a much better thing. If we cut it in half like this, so how many symmetric faces or symmetric sides do we get? We get two identical objects if we cut it in half, and we have cut this in this form, and then in this form, then in this form, and as how many, as many cuts as you can do here. So the number of planes of symmetry would be infinite planes. Again, part 1 is infinite, and the number of axes of rotation of symmetry, it is as about y-axis, so there is only one axis, so you have to write this as 1. We have next question, question number 11. A conical funnel of diameter 23.2 centimeters and depth 42 centimeter contained water filled to the brim. The water is poured into a cylindrical tin of diameter 16.2 centimeters. If the tin must contain all the water, find at least possible its least possible height, giving your answer to the nearest integer. Now, this question is, conical funnel is like this shape, a cone, an inverted cone, and filled to the brim means to this level. Its diameter is equal to 23.2 centimeters. So its radius will be half of this 23.2 divided by 2, and then we have given the depth 42, means from this point to this, which is the height of a cone. In general, we use it to be height. So h is equal to 42 centimeters. The water is poured into a cylindrical tin. Let's find out the total volume of the water before reading the question ahead. We have total volume of this cone is equal to 1 over 3 pi r square, and h, putting the values, we get 1 over 3 pi as it is. R square is 23.2 divided by 2 whole square, and h is 42. So solving this equation, what do we get is 1883 1883.84 pi. I have not inserted the value of the pi, as we have to solve this question further. So it's possible that pi would be cancelled or not. So this is centimeters cube total volume. Now, as this total volume of water is poured into a cylindrical tin of diameter 16.2. Now this water has been poured into a cylinder of this shape, and it has diameter 16.2. The volume of a cylinder is pi r square h. Now we have to convert this in, pour all this water in the cylinder, so its volume would be 1883.84 pi is equal to pi r square h, and 1883.84 pi is equal to pi as it is. where r square is 16.2's half, 16.2 divided by 2 whole square, and h we need to find. This pi will be cancelled by this, as we have assumed. So now 1883.84 divided by all this, 16.2 divided by 2 and whole square. Let's see what our calculator gives the value, and it is h equals 28.72, correct to three significant figures. H equals 28.7 centimeters, and as we had to give it to the nearest integer, so h is equal to 29 centimeters. Now, last question of this video: a conical block of silver has a height of 16 centimeters and a base radius of 12 centimeter. The silver is melted to form coins 1 by 6 centimeter thick and 1 whole 1 by 2 centimeters in diameter. Find the number of coins that can be made. So conical block of silver, we have to find the volume of the conical block, which is equal to 1 over 3. Again, the formula for the volume of the cone, pi r square h, and using the values we have, v is equal to height is 16 and base radius of 12, so 1 over 3 pi as it is. R is 12, so 12 square here, and h is equal to 16 centimeters. This total value gives the answer to be equal to 768 pi centimeters cube. This conical block of silver has a height of this. The silver is melted. Now all this volume has been melted, and we have formed coins which are 1 by 6 centimeters thick and 1 whole 1 over 3, 1 over 2 centimeters in diameter. Find the number of coins. So volume of one coin would be volume of coin. A coin is of the form of a cylinder, where this would be the thickness and this would be the diameter, and the formula for the volume of the coin is pi r square h. So pi as it is, r is as its diameter is 3 by 2 or 1.5, so its radius will be 1.5 divided by 2 whole square, and h is 1 by 6. So we are going to use these values like this. So volume of one coin becomes equal to, the calculator gives it to be equal to 3 over 32 pi, 3 over 32 pi centimeters cube. Now we have to find out that how many coins we can make of this volume out of this volume. So number of coins n would be equal to 768 pi divided by 3 over 32 pi, and this pi will be cancelled here. So 768 multiplied by 32 divided by 3, we get the value to be equal to 8192. 8192 would be the number of coins which we can make out of this. So in this video we have tried to solve question number 6 to 12 of exercise 7b. I hope that it may be a little help to your concepts. If you have any question, you can write in the comment section. Thank you very much.